All right, trigonometry. Let's do a review. Gonna move fast. Yes, we are going to have an ambiguous case, and yes, you are going to have to find both possible triangles. So, in order to do that, we need to use the law of sines. So, let's go for it. So, remember, we know little a and we know big A. So, 4 over sine 25 equals little b over the sine of b. We're going after acute angle sine, or acute angle b. So, using our calculator, remember, be sure we're in degree mode, and be sure your calculator's charged and ready to go. Cross multiply, and we see that the inverse sine of 6.2 times the sine of 25 divided by 4 is what little angle b is going to be equal to. So inverse sine of 6.2 times sine 25 over 4. Close that, and we see that acute angle b is 40.9. Round to the nearest tenth, please. Now, in order to get obtuse angle b, we simply have to take the supplement of 40.9. So 40.9 subtracted from 180 is 139.1. And then let's go ahead and find angle C, since we're right here. So remember, every triangle has an interior angle sum of 180 degrees. So we just need to subtract. So 180 minus 25 minus 40.9 gives us angle C at 114.1. And then flip over to obtuse angle B. Remember, angle A is fixed, so 180 minus 25 minus 139.1 means that angle C will be a little tiny, 15.9. So think about what we now know. We now know A, B, and C. There's three angles, A, B, and C. So we know little b. We just need to know little c for these two particular triangles. So let's go for it using law of sines. And I'm just going to utilize this given ratio once more. So 4 over sine 25 equals little c over the sine of 114.1. Now think about it. If angle C is 114.1, that is clearly going to be the biggest angle. Therefore, side C should be bigger than little b and little a. So cross multiply and solve. For the calculator, I will use the fraction key here. So 4 sine 114.1 over sine 25 gives us 8.6. Little c is 8.6. And check it out. So if little c is 8.6, 8.6 needs to be bigger than little a and little b, and that is true. So let's go to the other side over here where angle C is 15.9, so that's going to be a very, very small little c. So 4 over sine 25 equals c over sine of 15.9. Cross multiply to get little c. We're expecting little c to be quite small this time. So here's my fraction, 4 sine 15.9 over the sine of 25. So little c on this side of the aisle is 2.6. And of course, being that angle c in this triangle is very small, little c has to be smaller than b and a. It is. So there you go. That is your two-case ambiguous triangle law of sines problem. We will have one like that. Next, find the area. Find the area given angle C is 119, little a is 18, and little b is 6. So first of all, 119 is an obtuse angle. So if we put C here, that means that side C is across the way. We can put A here, which means little a is 18. And we can put angle B here, which would make our little b over here equal to 6. Now, if we have an obtuse, triangle, it's probably going to be necessary for us to drop an altitude on the outside. So I am going to drop that altitude right here and extend the base. Now remember, this is 119. So if angle C in the interior is 119, angle C in the exterior will simply be the supplement of 119. So 180 minus 119 is 61. So we have a 61 degree angle. Remember, this is a right triangle, so we can apply a sine function here in order to find the height. Remember, the 18 is the hypotenuse of the right triangle. So the sine of 61 equals the opposite over the hypotenuse, h over 18. And then from here, cross multiply to solve for h. So that is 18 times sine 61. Our height is 15.7. So if our height is 15.7 and our base is 6, we can now find the area of the triangle. Area equals 1/2 base times height. That is 1/2 times 6 times 15.7 to give us a final area of 0.5 times 6 times 15.7. The area of this triangle is 47.1, and we'll just say it's units squared. That's how we find the area of an oval triangle. Next, we want to solve a triangle given all three sides. Now, obviously, if we're given all three sides, all we can find is one triangle. No need to consider two possibilities here. And if we're given all three sides, this is a side-side-side presentation. This means we need to use the law of cosines. Now, my hint to you is to go after the smallest angle. The smallest angle projects the smallest side. So b squared equals a squared plus c squared minus 2ac cosine b. Have to know the law of cosine formulas. Plug it in. 8.8 squared equals 60.4 squared plus 12.2 squared minus, and I'm going to put this whole term safely in some grouping symbols to remind myself that it's one term. I'm not just going to subtract 2 and c. So 2 times 64 times 12.2 times the cosine of b. Now, in order for us to solve for angle b, we are going to need to utilize an inverse function. But let's simplify first. So 8.8 squared is 77.44. 16.4 squared is 268.96. 12.2 squared, 148.4, minus 2 times 16.4 times 12.2. So 2 times 16.4 times 12.2 is 400.6 cosine of b. Remember, that's multiplied by cosine b. So let's simplify and let's isolate this term. So 77.44 minus 268.96 minus 148.84 gives us negative 340.36. Remember, little b is the smallest, therefore angle b has to be acute. So negative 340.36 equals negative 400.16 cosine b. So instead of adding that, we will be dividing by negative 400.6, and we will get the cosine of B. We will use an inverse cosine in just a second. So negative 340.36 divided by negative 400.16 gives us a positive 0.85056, which obviously I'll just keep stored in my calculator. And remember, the range of the cosine only goes between negative 1 and positive 1. So if you get a number here that is bigger than 1, you have done something wrong. So let's find the inverse cosine here. And we find that angle B is approximately 31.7 degrees. So angle B is 31.7. It's acute. That's what we're expecting it to be. Now that we know angle B, we can utilize little b, and we can set up a ratio to use the law of sines. Let's do that. 8.8 over the sine of 31.7 equals, let's go after c next, so 12.2, which is little c, over the sine of c. Cross multiply and solve for c. So c is going to equal sine inverse of 12.2 times the sine of 31.7 over 8.8. So inverse sine, and plug that fraction in there. And we find big C, angle C, is 46.8. And obviously, if we know two of the angles, we can use the triangle angle sum theorem to find our remaining angle A, expecting it to be the biggest. So angle A is going to be what we get when we subtract 180 minus 31.7 minus 46.8. We find angle A to be 101. A, B, C. All three angles, we have solved the triangle using the law of cosines. Next, we're going to change to rectangular coordinates given polar coordinates. Remember, this is R and this is theta. And the things that you must know for our test are x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tan theta equals y over x. So, if we wanted to plot this on the polar plane, we could totally plot this on the polar plane. I'll just quickly frame it right here. Remember, you rotate first. So if we rotate to 5 pi over 6, that is going to be about right there. Remember, that's going to have a 30-degree reference angle right there. And if we go out 4, 1, 2, 3, 4, we're talking about a point right there located in quadrant 2. So whatever we get for our rectangular coordinates also have to be in quadrant 2. So let's use our things, our x and our y, and let's find out what they are. So x equals 4 times the cosine at 5 pi over 6. And y equals 4 times the sine at 5 pi over 6. So, of course, at 5 pi over 6, the cosine is negative root 3 over 2. And at 5 pi over 6, the sine is positive because it's in quadrant 2, and it is positive. So 4 times negative root 3 over 2 to cancels, and we get negative 2 root 3. And then half of 4 is 2, which makes sense because we are further out and we are up. So back to negative 2 root 3, up to, that's in quadrant 2. That is going from polar to rectangular. Now keep this in mind as we switch from rectangular to polar. So this is x, this is y. Now if I were you, before I did anything, I would quickly just freehand plot negative 8, 0. So back 8, up 0. Now, if we had to get a rotation to get all the way over, that looks like it's going to be pi. So over pi and then out 8. So the answer here is going to be 8, comma, pi. Let's see why that is true. Remember, this is x, this is y. And x squared plus y squared equals r squared. So negative 8 squared plus 0 squared equals r squared. So 64 equals r squared. Therefore, r is 8. Check. There it is. And then after that, we know that tan theta equals y over x. So 0 over negative 8. Tan theta equals 0. Well, if we know that we are on this side of the x-axis, then theta has to be, and tan theta is equal to 0. That means it's not 0. That means it must be pi. Theta is pi. So that is actually how we prove it using the givens. Next, we've got another rectangular. Remember, this is x, this is y. So we are negative 2 root 5, positive 2 root 15. So again, I don't know exactly where and what these are. Obviously, you could find the decimal approximations, but clearly y is a bigger number than x. So we are going to be looking about back 2 root 5, up 2 root 15, looking like we're about right there. That, of course, is in quadrant 2, which means our theta is going to be between pi over 2 and pi. Anticipate what your answer should be before you do any problem. So let's use x squared plus y squared. So x squared plus y squared equals r squared. So that is negative 2 root 5 squared plus 2 root 15 squared equals r squared. Think about order of operations here. Negative 2 squared is 4, root 5 squared is 5, negative 2 root 5 squared is 20. 2 root 15 is 2 squared, which is 4, root 15 squared is 15, and 2 root 15 squared is 60. So we end up with 20 plus 60 equals r squared. That is 80 equals r squared. Square root. 80 is 16 times 5. So our r value is 4 root, not 15, but 4 root 5. 4 root 5 is r, because that's the square root of 80. Now, that's our first part of our answer. 4 root 5. Okay? Next, use tangent. So, tan theta equals y over x. So that is 2 root 15 over negative 2 root 5. So 2's cancel, and root 5 goes into root 15 3 times. We end up with negative root 3. Now, that makes sense to me, and if we are in quadrant 2 and our tan value is negative root 3, that either has to be 30 or 60. And since this particular point is farther up than it is out, I know that it has to be 30. Or excuse me, I know that it has to be 60, which is going to be pi over 3, 2 pi over 3. So theta is 2 pi over 3. Obviously, you can check that out by using y over x or using your inverse tangent function on the calculator. So there's your r and there's your theta. We are going to be changing these rectangular equations to polar using our same 4 things to remember. And letter A is super easy because we can make a quick direct substitution for x squared plus y squared. X squared plus y squared is simply r squared. So if r squared equals 81, square root, r equals 9. So x squared plus y squared is a circle. This is a circle with center point at the origin and has a radius of the square root of 81, which of course is 9. Next, if x equals 5, well, we got to think about what is x equal to. X is equal to r cosine theta. So let's replace x with r cosine theta, set that equal to 5, And then to solve for r, we simply need to divide both sides by cosine. So we end up with 5 or r equals 5 over cosine theta. You can say that. That is also equivalent to simply 5 times secant theta. Both of those are correct answers. All we're doing is making substitutions here. Let's make a quick substitution here for x and y. 3 times x, x is r cosine theta, plus 2 times y, y is r sine theta equals 12. From here, remember the goal is to solve for r. R on the left-hand side of the equation is the greatest common factor. Take it out, and we get r times 3 cosine theta plus 2 sine theta equals 12. From there, we just need to divide both sides by 3 cosine theta plus 2 sine theta. And use some of that side's space. And cancel, cancel. That is the answer. R is equal to 12 over 3 cosine theta plus 2 sine theta. We're going to do this the same way we did letter B, just up above, except it's equal to y. So when we make our substitution here, y is equal to r sine theta. So r sine theta equals 4. Divide by sine theta. Divide by sine theta. R equals 4 over sine. You can leave it 4 over sine, or the reciprocal of sine, of course, is cosecant. 4 times cosecant theta. For problems, scholars, we're going to be going from polar to rectangular. As we talked about in class, sometimes it's necessary to square both sides. Sometimes it's necessary to just multiply by r. In this case, we need to multiply by r. Whoa, I'm telling a lie. This is r equals 4. This is the time to square. Square both sides, and we get r squared equals 16. Make a direct substitution. X squared plus y squared equals 16. Call it a day. That is the standard form of a circle. And letter B, here we go. Here is where we want to multiply both sides by r times r times r. R squared equals 5r sine theta. And now we're going to do a substitution for the r squared, which is x squared plus y squared. And of course, r sine theta is equal to y, so this is y. Now, you can go further from here and complete the square, but honestly, ladies and gentlemen, I'm going to be thrilled if you make it that far. This next one should look familiar, being that we just did one very similar to that. So whenever you see one of the reciprocal functions, I would rewrite it in terms of sine or cosine. So this is r equals 2 over sine theta, and then I'm hoping that you then see that you can just cross multiply. R times sine theta equals 2, and of course r sine theta is equal to y, so y equals 2. And then lastly, letter D, if theta equals negative 5 pi over 3, the only given that we have that helps us deal with theta is going to be applying the tangent function to both sides. So tan theta equals the tan of negative 5 pi over 3. So utilize your vast knowledge of the unit circle. Negative 5 pi over 3, so that's 1, 2, 3, 4, 5. Negative 5 pi over 3 is up here in quadrant 1. It has a 60-degree reference angle, so that is going to be equal to root 3. So, because it'll be root 3 over 2 divided by 1/2, and that equals root 3. So we end up tan theta equals simply root 3. If you want to put it over 1, that's fine. Then, when we replace the tan theta with y over x, we can then cross multiply. Y times 1 equals x times root 3. So x times root 3. And that is the answer. There you go, ladies and gentlemen. That is a comprehensive review, and we are going to have problems just like these on our test on Friday. Do good work.